Hello, everyone. Welcome. Thank you so much for joining us today. Let's give it a few minutes to let everybody trickle in. Good morning, good afternoon, good evening, depending on where you're joining us from today. We want to welcome you to today's webinar, Leveraging AI to Drive the Automotive Industry Forward. I want to start off by introducing myself. My name is Paula Ferreira, and I'm a marketing specialist here at the Virtual Forge based in Portugal. And with me today, we have Jason Casey, data scientist here at the Virtual Forge based in the UK, who you will be hearing a lot more from today. In this session, we're going to be exploring the transformative power of artificial intelligence within the automotive industry. And the key topics that we're going to be covering and what you will be learning about today include the benefits of AI in automotive, some common AI applications for automotive, best practices for implementing AI, and an outlook for the industry with today's ever-evolving technologies. So a few things before we dive in. We encourage you all to ask any questions you might have and participate throughout the duration of the webinar. So if you have any questions or comments, please leave them down below in our chat here live on LinkedIn. And we will be having a Q&A at the end of the session. So Jason will answer any questions that you may have. And don't worry, we will be sending you a copy of the slide deck and a recording of the webinar. So those resources will be sent out to you, and any other important information we'll send out as well. Do we have any questions so far? Alrighty, awesome. So Jason, I'm going to hand it over to you for a quick intro, and then we can go ahead and get started.
Thank you, Paula. Hi, everyone. I'm Jason. Happy to see everyone here today, and welcome to our webinar. As Paula said, we're going to talk through leveraging AI specifically in the automotive industry. And yeah, please feel free to submit those questions for us to revisit at the end. With that said, Paula, we can get started.
Yeah, let's get started.
Welcome, everyone, and thank you for joining today's webinar, Leveraging AI to Drive the Automotive Industry Forward. I'm Jason Casey, data scientist at the Virtual Forge. I'm excited to have you here and to share some valuable insights on how artificial intelligence is revolutionizing the automotive sector. The purpose of this webinar is twofold. First, we aim to provide an overview of the benefits and applications of AI in the automotive industry. We'll explore some of the ways that AI is transforming various aspects of the automotive landscape, from research and development to manufacturing, and from customer experience to insurance and risk assessments. Second, we want to equip you with the knowledge and strategies necessary to successfully implement AI in your automotive business. We'll discuss some best practices for overcoming common challenges and share insights on how to choose the relevant AI solutions for your specific needs. By the end of this session, you'll have a deeper understanding of AI's potential in the automotive sector, as well as insights which help you navigate the AI landscape and make informed decisions for your organization. But first, let me tell you a bit about the Virtual Forge. Our mission is to build data-rich and intelligent platforms by deeply understanding the systems and infrastructure needed to solve each client's unique business challenges. We believe in a collaborative and transparent approach that seeks to understand an organization's pain points and goals, then leverage reliable, proven tools overlaid with innovative development to create high-quality, customized solutions that address those specific needs. With a proven track record across 4 thriving sectors: manufacturing, life science, automotive, and financial services. We're proud to be a trusted global software development partner known for delivering comprehensive, business-focused solutions that equip organizations with the cutting-edge technology they need to succeed. Who am I? I'm Jason Casey, a data scientist working at the Virtual Forge. I've been working here for the last 3 years and within parts of the automotive industry for the last 10 years. Throughout my career, I've seen the increasingly transformative power of AI. Some relevant projects I've worked on include customer segmentation and classification models that analyze behavioral data to optimize pricing and profitability for a logistics company, an information discovery and tagging system using advanced natural language processing to improve searchability and insights from massive textual databases, and a generative AI-powered content analysis and search tool that enables users to extract answers and insights from diverse data types, documents, videos, images, dashboards, and more. These experiences have shown me that when leveraged effectively, AI can drive remarkable improvements in efficiency, insight, personalization, and most importantly, performance. But before we dive into specific applications, let's align on some key AI concepts. At a high level, AI involves creating intelligent applications that can perform tasks which typically require human intelligence. One of the key building blocks of these systems is machine learning. We have natural language processing, which enables effective human-computer interaction through speech and text. Reinforcement learning allows AI systems to learn decision-making through repeated trial and error. Deep learning uses complex, multi-layered neural networks to process data, recognize patterns, and also make decisions, often mimicking the human brain. And computer vision enables computers to interpret and understand visual information from the real world. Complementing and providing the data to support this, we have sensors, allowing perception and measurement of the environment. Next up are digital twins. These are virtual replicas of either physical objects, systems, or processes, which use real-time data and simulations to mirror its behavior and performance. Lastly, generative AI refers to a class of artificial intelligence algorithms that can create new, original content based on learned patterns and rules. These systems are trained on vast data sets of existing content, such as text, images, or audio, and learn to recognize the underlying structure and style of that data. They can then use this learned structure and style to generate new content. Now let's move on to AI in the automotive industry specifically. This industry is one of the largest in the world at $2.5 trillion in annual revenue, and it is undergoing a dramatic AI-driven transformation. From enhancing in-vehicle experiences to optimizing manufacturing, supply chain and aftermarket services, AI is being infused across the automotive value chain. The numbers speak to AI's growing importance in this sector. Already valued at an estimated $32.5 billion, it is projected to double in the next 5 years alone, and it is very clear that companies not embracing AI risk being left behind. So, first, let's discuss why are automotive companies even racing to adopt AI? The benefits are significant and wide-ranging. AI-powered systems like collision avoidance, pedestrian detection, and driver monitoring are making vehicles safer than ever. This differs slightly by country, but in general, over 90% of car accidents today involve human error. By minimizing that error, AI could help save millions of lives. By leveraging advanced analytics and machine learning algorithms, automotive companies can predict demand more accurately, ensuring the right inventory is available at the right time. This not only boosts customer satisfaction, but also reduces holding costs and waste. All these efficiency gains translate to major cost savings. Predictive maintenance, for example, can reduce maintenance costs by around 10 to 20% versus typical preventative maintenance, while also improving vehicle uptime. AI enables vehicles to understand and adapt to each driver's unique preferences and needs for a tailored, delightful user experience. By delivering personalization, proactive service, and seamless user experiences, AI boosts customer satisfaction and loyalty. At a strategic level, AI turns the treasure trove of automotive data into actionable insights, enabling better, faster decisions across the organization. Now let's dive deeper into some specific applications helping to deliver these benefits. AI-powered learning tools are transforming how automotive companies manage and share knowledge. By leveraging techniques like natural language processing to automatically tag and organize content, these systems make it easy for employees to find the information right when they need it. Imagine a technician instantly accessing step-by-step repair guides for a new electric vehicle, or a salesperson quickly finding the perfect case study to share with a hesitant buyer. That's the power of AI in learning, connecting people with knowledge at the moment of need. At Virtual Forge, we've built AI-powered information discovery systems that use named entity recognition to automatically tag and link concepts across vast technical documentation libraries. This enables employees to find answers with a simple search, reducing wasted time and accelerating problem solving. Other applications of AI in learning include intelligent content recommendation engines that automatically surface relevant training based on an employee's role, skills, and performance data, as well as generative AI tools that can automatically create and personalize learning content at scale. As vehicles and the skills needed to design, build, and service them grow more complex, these AI-powered learning tools will only become more essential, helping automotive workforces keep pace with the rapid rate of change and deliver better results faster. AI is transforming material science, enabling researchers to analyze vast data sets and predict the properties and performance of novel materials and composites. This accelerates the discovery and development of lighter, stronger, and more sustainable materials for next-generation vehicles. In the realm of testing and validation, AI-powered simulation and digital twins allow manufacturers to virtually test and refine new products and processes before committing to physical prototypes. By accurately modeling these complex systems and subjecting them to countless simulated scenarios, engineers can identify and resolve potential issues early, reducing development time, cost, and risk. Finally, generative AI can be used to streamline R&D documentation and knowledge management. Generative language models can automatically synthesize technical reports, patent applications, and other critical documents, saving engineers valuable time. Natural language processing can also help researchers quickly find relevant information across vast libraries of past projects, enabling them to build on existing knowledge and avoid duplicating effort. Perhaps the most talked about AI application in automotive is autonomous driving. The Society of Automotive Engineers defines 6 levels of driving automation. At level 0, the driver performs all tasks. At level 1, the vehicle can control either steering or acceleration and deceleration, but the driver must be ready to take control at any time. At level 2, the vehicle can control both steering and acceleration and deceleration at the same time. At level 3, the vehicle can perform all driving tasks under certain conditions, but the driver must be ready to take control when those conditions are not fulfilled. At level 4, the vehicle can perform all driving tasks under most conditions without human intervention. And finally, at level 5, the vehicle can drive itself under all conditions with no human involvement. Most new vehicles sold today are classed as level 2, letting you use technology like adaptive cruise control and lane keeping together. Up to level 2, the driver is always responsible for the management of the vehicle. From level 3, the vehicle itself is in charge, subject to the operating conditions, and as such, the manufacturers themselves are required to take legal responsibility for any accidents that occur while their system is active. As it stands today, there is only one Level 3 enabled system available on the global market, Drive Pilot, recently launched by Mercedes-Benz in Germany and Nevada. AI usage here, especially for vehicle perception, decision making, and control, increases significantly as we move up these levels. Deep learning algorithms fuse data from cameras, radar, LiDAR, and other sensors to perceive the environment, detect objects, predict behaviors, plan routes, and control vehicle motion. The impacts on safety for this technology are expected to be significant. Research carried out in America on vehicles with driver assistance technologies equipped, those the ones found in level 1 and 2 vehicles, suggest that around 40% of crashes that happen each year and 29% of deaths could be prevented if all vehicles just had these technologies equipped. AI is revolutionizing the in-car experience, making it more intuitive, personalized, and engaging than ever before. One key technology powering this transformation is natural language processing. By leveraging deep learning algorithms like recurrent neural networks and transformer models, NLP systems can accurately interpret spoken commands and engage in natural, context-aware dialogue with drivers. This enables hands-free control of vehicle functions like navigation, climate, and media, enhancing convenience and safety at the same time. Computer vision, powered by convolutional neural networks, are another critical AI technology reshaping the in-car experience. By analyzing images and video from in-cabin cameras, computer vision systems can detect and respond to driver behavior and state in real time. For example, driver fatigue detection systems use CNNs to monitor visual cues like eye blinking, yawning, and head nodding, which may indicate drowsiness. If the system detects signs of fatigue, it can alert the driver, suggest a rest stop, or even initiate safety measures like slowing the vehicle. Recommendation engines, like those used by Netflix or Amazon, are being deployed to offer personalized suggestions for vehicle features, settings, media content, routes, and more based on analysis of the driver's past behavior and preferences. Manufacturing optimization employs AI to streamline production processes in the automotive industry. Algorithms analyze numerical and image data from various stages of manufacturing, predicting equipment failures and supporting processes to optimize assembly line operations. This data-driven approach enhances efficiency, reduces costs, and elevates product quality. In supply chains, machine learning-based demand forecasting helps to reduce inventory costs by ensuring the right parts are available when needed. Logistics and delivery scheduling coordinates just-in-time delivery of components, keeping manufacturing operations running smoothly. This AI application plays a crucial role in meeting production demands and maintaining high standards across the automotive manufacturing process. Intelligent traffic management leverages AI to analyze real-time traffic data from sources like GPS and surveillance cameras. By processing this information, AI algorithms optimize traffic flow, reduce congestion, and enhance road safety. Adaptive traffic signal control systems can adjust signal timings based on traffic conditions, easing bottlenecks within the road network. Navigation systems powered by AI algorithms bring advanced capabilities built on top of traditional GPS systems. The algorithms in these systems offer optimized routes that consider and plan around current circumstances by integrating real-time data from various sources such as traffic information, road conditions, weather updates, and even driver behavior. Route optimization utilizes AI to find the most efficient and cost-effective routes for vehicles between sets of points. By analyzing data such as traffic conditions, road closures, and delivery schedules, these algorithms determine optimal paths that minimize travel time and fuel consumption. This is crucial for commercial vehicles like delivery trucks or service vehicles to ensure timely deliveries and reduced operational costs. AI enables predictive maintenance by continuously monitoring the health of key components and identifying potential failures before they occur. One prominent example of this is General Motors' OnStar system. By leveraging AI to analyze real-time vehicle data, OnStar can predict when certain components, like the battery or starter motor, are likely to fail, and it then proactively notifies the driver and schedules a service appointment at a convenient time, often before the driver even realizes there's an issue. This helps avoid unexpected breakdowns and costly repairs while giving drivers added peace of mind. Digital twins allow manufacturers and service providers to diagnose and even resolve many issues remotely, without the vehicle ever needing to visit a physical service center. In sales and marketing, AI analyzes customer behavior across touchpoints like website interactions, dealership visits, and vehicle usage to deliver deeply personalized offers and experiences. Similarly, marketing campaigns can be analyzed for effectiveness in affecting their target metric, enabling data-driven decision-making for future campaigns. An individual shopping for a new SUV might receive tailored recommendations down to the specific trim, options, and color based on their unique preferences and needs, with the ultimate aim of increasing conversion and revenue. Conversational AI chatbots using generative AI can provide instant 24/7 responses to customer inquiries, improving satisfaction while also reducing the cost to serve. Sentiment analysis of social media posts and product reviews help companies identify and proactively address quality and reputation issues. Telematics devices collect data on driving behavior, including speed, braking patterns, acceleration, and more. AI algorithms analyze this data to create accurate driver profiles, assessing individual risk levels. Insurers can offer personalized insurance rates based on these driving habits, rewarding safer drivers with lower premiums and encouraging responsible behavior on the road. Additionally, AI can predict accident probabilities based on historical data and real-time conditions, allowing insurance companies to make more informed decisions about coverage and risk mitigation strategies. To succeed with AI, automotive companies must address common obstacles and follow proven best practices. One of the biggest challenges is data quality and integration. AI systems require accurate, clean, and well-structured data from various sources. However, many automotive organizations struggle with data silos, inconsistencies, and gaps that hinder AI performance. Overcoming this obstacle typically requires establishing robust data governance frameworks and data cleansing processes to ensure a reliable foundation for an AI project. Another critical issue is algorithmic bias and lack of explainability. If not properly addressed, biased AI systems can lead to unfair or even dangerous outcomes, such as discriminatory pricing or unsafe vehicle behaviors. It's crucial that automotive AI solutions undergo rigorous bias testing and that their decision-making processes are transparent and auditable. This helps build trust with customers and regulators. Talent scarcity is another common roadblock. As demand for AI skills soars, automotive companies often struggle to attract, develop, and retain the necessary expertise. Overcoming this challenge requires a multifaceted approach, including upskilling existing staff, partnering with academic institutions, and creating compelling career paths and employee value propositions. Organizational misalignment can derail AI initiatives. If AI projects are disconnected from core business objectives and processes, they may fail to deliver any meaningful results. Ensuring AI alignment with business objectives requires close collaboration between business, IT, and data science teams, as well as clear leadership support and governance structures. How can you overcome those obstacles when defining your AI project? When looking for partners to support you, you should look for ones that can support a modular, scalable architecture that can adapt to your evolving needs. Avoid rigid, monolithic legacy systems that are difficult to modify as your business changes. The best AI platforms are flexible and can easily incorporate new data sources, models, and even use cases over time. Interoperability and ease of integration are also crucial. Your solutions should work seamlessly with your existing systems and processes, from data ingestion to results visualization. Data governance and transparency should be key evaluation criteria. Look for platforms with clear data management policies, secure access controls, and audit trails. Partners should be transparent about how they collect, store, and use your data, as well as how they train and validate their models. This transparency is essential for building trust and ensuring compliance with regulations like GDPR. Finally, consider your AI provider's track records in the automotive industry. Have they successfully delivered measurable business results for similar use cases? Do they deeply understand the unique challenges and opportunities of automotive AI? Partnering with experienced automotive-focused companies can help you avoid all of the common pitfalls. So what strategies can you adopt to help lead to a successful AI project? So what's next? We can expect AI to become more and more infused into every facet of the automotive industry, but there are some key trends that appear to be on the horizon. Edge computing and 5G connectivity are enabling vehicles to process AI workloads locally in real time for faster, more reliable decision making. The expansion of vehicle-to-everything communication is leading to AI-powered vehicles not just sensing, but actively communicating with pedestrians, infrastructure, and other vehicles to enable collaborative optimization of traffic flow and safety. The increasing proliferation of AI-generated content and experiences will continue to change the driving experience, with generative AI creating hyper-personalized driving settings, in-car media, games, and even interior designs. Based on these trends, we can make some predictions about the future of the automotive industry. In the next 10 to 15 years, it seems like autonomous vehicles will become ubiquitous, first in controlled domains like motorways and urban centers, and eventually in all environments. This will reshape mobility, enabling new vehicle form factors and business models like autonomous ride-sharing and subscription-based transportation as a service solutions. Human drivers will still have the option to take the wheel for leisure, but driving will become more of a hobby than the primary mode of transport. It's possible that the costs of insurance for manual driving will take that option away from the masses as part of the transition to autonomous vehicles, and it will become the only cost-effective option. AI will play a larger role in optimizing traffic flow and reducing congestion in cities. Intelligent traffic management systems will communicate with autonomous vehicles to dynamically route traffic, adjust speed limits, and control traffic lights based on real-time conditions. This will lead to smoother, safer, and more efficient transportation networks. The rise of autonomous vehicles and AI-optimized traffic will also have implications for urban planning and design. With less need for parking spaces and fewer accidents, cities may be able to reclaim land currently used for parking lots and roadways. This could lead to greener, more pedestrian-friendly urban spaces. Inside the vehicle, AI will continuously personalize and enhance the passenger experience. Intelligent assistants will learn individual preferences and anticipate needs, providing customized entertainment, information, and recommendations. Vehicles will become more like extended personal living spaces, with adaptive interiors that can transform for work, relaxation, or socializing. AI will support the development of electric and alternative fuel vehicles. Machine learning will optimize battery management, charging efficiency, and energy recovery, extending vehicle range and reducing costs. Predictive maintenance enabled by AI will keep these complex vehicles running smoothly and prevent breakdowns. Everything sounds great and exciting, but the implementation of this technology comes with many potential risks. The automation of jobs is likely to have a large impact on the automotive workforce, potentially displacing millions of taxi, rideshare, and truck drivers. Algorithmic bias within AI systems risk perpetuating or amplifying societal inequalities in mobility access and service quality. There are privacy concerns around the massive amounts of personal data collected and analyzed by vehicle AI. Cybersecurity vulnerabilities in vehicle design could allow bad actors to hack and weaponize vehicles. The erosion of human driving skills as less people drive manually could lead to a potential loss of freedom or autonomy as people become more and more dependent on AI for mobility. To mitigate these risks, it's critical that automotive and AI leaders engage in proactive, responsible development focused on beneficial outcomes for individual users and society as a whole. This requires upskilling and reskilling workers displaced by automation for new roles in the AI-driven mobility ecosystem, instituting bias testing, explainability, and oversight in process to ensure equitable treatment across different demographic groups. Implement robust governance around data collection, usage, and protection. Baking in security and fail-safe into system design from the ground up. Preserve human agency and the ability to override AI systems as and when needed. And we'll need substantial investments in public education and discourse around the societal implications of AI-driven mobility. Now, I'd like to spend a couple of minutes discussing a product we've built at the Virtual Forge and how it can integrate with everything we've discussed today. My Content Scout is an advanced AI content analysis and search tool designed to enhance the way users find and gain valuable insights from various different types of data across an organization all at once. It is a cloud-first platform designed to provide an interface in which users can ask natural language questions about any existing content they have across a vast array of content types. You can query documents, videos, audio files, images, dashboards, and more in natural language to extract the insights you need from your data. How does it work? Users ask questions in natural language. How do I create a new invoice on our platform? What should I be aware of when replacing the tires on a particular model? And so on. My Content Scout scours the business's content. It extracts images from existing videos and documents. It tags those images with entities represented. It transcribes video and audio content. It extracts metadata about their dashboards and more. All of this is fed into the user's search to extract the relevant content they need for their query. It provides an AI-generated summary of that relevant content. It shows them what pieces of content were used to create that summary, where that content is located, and so on. This gets the end users to what they actually need as soon as possible. AI is not just an exciting new technology, but a transformative force that will reshape the automotive industry and society as a whole. From enabling autonomous driving to optimizing manufacturing, personalizing user experiences, and creating new mobility services, AI's potential impact is hard to overstate. We're already seeing remarkable breakthroughs in vehicle safety, efficiency, sustainability, and convenience thanks to AI. However, automotive AI is also not without risks and challenges that must be proactively addressed through responsible development practices focused on ethics, equity, transparency, and security. At the Virtual Forge, we've helped some of the world's leading automotive brands do exactly that by providing end-to-end AI services, from data and strategy to model development, deployment, and scaling. To learn more about how we can help you accelerate your AI journey, I encourage you to visit our website or reach out directly. We'd love to learn about your business challenges and discuss how AI can help. Thank you again for joining today's webinar. I hope you found it valuable and it has made you think about how AI could integrate with your business. With that, I'll open it up for Q&A, so please let me know if you have any questions.
Amazing. Thank you so much, Jason, for that insightful presentation. So thank you so much to everyone also for attending. Like Jason said, we're now going to open it up for a Q&A. If anyone has any questions, feel free to drop them down in the chat or message us directly here on LinkedIn. You can also send us any specific questions that you may have to our email, connect@thevirtualforge.com, where we will be happy to answer any questions and get back to you. So, alrighty. So our first question is, what are some specific examples of how generative AI is being used to create personalized content for automotive customers?
Okay, thanks, Paula. So generative AI, we all know it's revolutionizing really, how automotive companies can tailor their content and their experience for their customers. Some of the examples that we've seen, there've been, customer service chatbots. In some cases, we've seen AI-powered knowledge management and training, similar to what we showed there a little bit with My Content Scout, and retrieval augmented generation for personalized recommendations. So with the chatbots, these can offer tailored maintenance advice or troubleshoot specific problems people are facing, and in some cases even suggest upgrades or features available to you based on how you might use your vehicle. In the retailers and the service centers, one of the challenges they have is, keeping everyone trained and up to date on the changes with the vehicles. Generative AI is often used here to create personalized training modules for technicians or for salespeople, keeping the staff, trained up on the exact engine in the cars that they're working on, or the knowledge that they need to sell that new vehicle, the things that the retailers care about most. And then I mentioned the retrieval augmented generation. This combines, the power of generative AI with your own data. So companies are gathering information on how to use their vehicles so that they can use this to provide recommendations tailored to you going forwards, like suggesting specific model that might fit your use case, or safety features, or even color option that you might most prefer.
Amazing. Thank you so much for that. And we have another question here. How can small to medium-sized automotive businesses get started with AI implementation, given the resource constraints that they might face?
Okay, so I think it's a common misconception to think you need to be a large organization to work in this space. But by considering a handful of things, any size company can work with this kind of technology. So some of those things we covered there in the webinar were things like prioritize the high impact areas. Don't try to do everything at once. Don't try to solve every problem. Pick the one that can make the biggest difference. Be very focused, and then start small and scale up with that problem. Have a pilot project, be successful with it, and then it becomes easier to expand this technology with it throughout the business. The other one is the misconception about like hardware. Leveraging cloud-based solutions. You don't need to build everything yourself from scratch. There's a lot of pre-built things that people can use, affordable AI tools and platforms already available in the cloud, and you pay for your usage. You don't pay to have extensive hardware and so on. And then partnering with experts. If your company doesn't have in-house AI expertise, it's pretty normal to partner with consultants or agencies that do have expertise in this area, and particularly, experience throughout the automotive industry. And then there's also, focusing on your data. One of the most important parts is clean, accurate data. It's essential for interacting with the models and getting reliable results. So making sure you have all that together, it's well organized and accessible and well documented and so on. And then by starting small, focusing on all of these points we just discussed, you can do this at any size business. It doesn't matter if it's small or large.
Amazing. Awesome. Thanks so much, Jason. And it doesn't look like we have any more questions. So I think that's a wrap for today. Just a reminder that we will be sending a recording of the webinar and the slides as well. So look out for that. And thank you so much to everyone for joining. And we hope to see you at the next one. Thanks so much, Jason, again.
Thank you, Paula. Thank you, everyone.